Alright guys, so this is the review for Exam 5. If you're Monday, Wednesday, Friday, you might want to fast forward this because you probably have already seen this example before, but I think my Tuesday, Thursday course has not, so I'm gonna do this one again. So 100 people were surveyed on their interest in basketball, baseball, and football, and the following were found. So I want to remind everybody, how do we do this problem? All right, the idea is we have 3 circles and we have 3 categories, and so we label each circle. We'll have a basketball circle, so I'll just write bask. We'll have a baseball circle, so I'll just write base. And then, of course, we'll have a football circle, so I'll just write foot. Right. So basketball, baseball, and football. And what we want to do is we want to answer a bunch of questions. So if we look on the next page over here, there's a bunch of questions here. And we want to answer, how many of these students in the survey are interested in basketball and so on. And that should say people, not students, but it doesn't matter. All right, so you come back here, and the way this works is you start from the bottom, the one where they're interested in all 3. So 10 people are interested in all 3, so you put it in the right spot. So that spot says 10 are interested in all 3. 25 are interested in football and basketball. So here's football and basketball. You already counted 10, right? In between here you have 25, and so you put 15 here because these two numbers should add to 25. So we got that one, we did that one. 15 are interested in baseball and football, so we have 15, right, within this region. We already counted 10, so we put 5 there. So we counted those. And then 20 are interested in basketball and baseball. So here's basketball and baseball. And we have 20. We've already counted 10, so we put 10 there. And then 55 are interested in football. So that's 15, 10 is 25, 30. And so we have 55, so we put 25 here. Are interested in just football. And then 45 in baseball. Okay, so we have 10, 10, 25. To get to 45, we need a 20 here. And then finally in basketball we have 40, so we have 25, 35, and so you just have 5 interested in basketball. Okay. And so what this tells us is basically how to answer the following questions. All right, how many are interested in basketball only? So you just have 5 there. Are interested in football but not baseball. So here's all the football people, but not baseball, so don't count these. So 15 plus 25. And so that's 40 people. Interested in just one of these sports, right? So 5, 20, and 25, right? So 5 are interested in just baseball, 5 in just basketball, 20 in just baseball, and 25 in just football. All right, so that's 50, 40, 35, 45, 50. Are interested in exactly 2 of these sports. Okay, so that's this number here, 15, 5, and 10. So we have 3 numbers, 15, 5, and 10. And so that gives me 30 people are interested in none of these sports. And so now here I have to do a little bit of work. So 100 people total were surveyed, and I take off the combined total of these numbers. So 5 plus 10 plus 20 plus 15 plus 10 plus 5 plus 25. So the total of 90. So 10 minus 90, which gives me 10 people. And so 10 people aren't interested in any of these sports. And then are not interested in basketball or football. So here's basketball and here's football. So none of these numbers. So 20, but don't forget the extra 10 outside that aren't interested in any of the sports. So 20 plus 10, which is 30 people. All right, so I wanted to go through that for the Tuesday, Thursday course. Okay, so here's what we covered. And so let's do a little bit of a review here. So the first thing we covered was on what's called inductive and deductive reasoning. So these 2 different types of reasoning. Remember, inductive reasoning, the idea is you go from specific cases to sort of a general statement. Right? So you're making your conclusion off specific cases. Whereas in deductive reasoning, you're going from some sort of general principle and applying it to a specific case usually. Let's take a look at an example of this. So on Exam 5 review, number 1 says determine whether the reasoning is an example of inductive or deductive reasoning. So Bob's last 3 vehicles were trucks, therefore his next vehicle will be a truck too. Okay, so this is an example of inductive reasoning, right, because you're going from these past 3 examples and then concluding something in the future. Now it might be that Bob gets tired of his truck and buys a sedan, right? But it's not deductive, right? You're not going from a general principle. Some specific cases applied to the next situation. So this is an inductive reasoning. The next example, number 2, Jeff's sister is exactly 3 years younger than him, and he is 24. Therefore, his sister is 21. Now, this is deductive reasoning. All right, the reason why it's deductive is because you're going from, in a sense, a general principle, right, a fact. Right, Jeff's sister is exactly 3 years younger than him, and he is 24. Right, so from these 2 assumptions, then we can conclude that since he's exactly 3 years younger, his sister is 21. All right, part C, all my friends hate Jennifer, therefore I will hate Jennifer. So this is an example of inductive reasoning. You're going from the specific cases, your friends, and making a conclusion. So inductive reasoning. All right, and so on the next one, let's go back to the. All right, so that's how we work inductive and deductive reasoning. All right, then within this section, we talked about what are called sequences. Remember, a sequence is just a list of things. So you could have like the sequence. Let's just do like 1, 2, 3, ... on and on and on and on. And we talked about 2 different types of sequences, arithmetic and geometric. Remember, arithmetic sequences, the idea is you add the same number each time. A geometric, instead of adding, you're multiplying a number each time. So let's look at some examples of this on the review. And so here in number 2 it says use inductive reasoning to determine the next term in the sequence, and use deductive reasoning to classify the sequence as arithmetic, geometric, or neither. Okay, so when we look at this first one here, 16, the first thing I'm thinking is, okay, well maybe I'm adding 10, right? Because I take 6 plus 10 to get 16. But if I add 10 to 16, I don't get 38. So that doesn't work. Then maybe I'm multiplying by some number. Well, to get to 16, from 6 to 16, you have to multiply by 16 over 6. And then you multiply 16 by 6 over 6. If you multiply 16 by 16 over 6, you will not get 38. All right, so this is an example of a sequence that is neither arithmetic or geometric. So this is neither. So let's put that over here. All right, so what's going on here? To figure out the next term, right, what we're going to do is we're going to do this method of successive differences, or we're just going to create this web. So the idea is you take the difference between these numbers. So the differences between 6 and 16 is 10. All right, the difference between 38 and 16 is 22. The difference between 78 and 38 is a 40. And the difference between 78 and 142 is, I believe, 76. And let's check it, though, just to make sure. So 142 minus 78, oops, way off, 64. Good thing I have a calculator. All right. All right, 64. Okay, and then I take the differences again. So 22 minus 10 is 12. 40 minus 22 is 18. 64 minus 40 is 24. And then 18 minus 12 is a 6. 24 minus 18 is a 6. And then I put now, let's pause here for a minute. Now, what do? I recreate this web. I know the bottom row should be a 6, so I put a 6 here. And I ask myself, what number goes here when you take away 24? You get a 6, and that's obviously 30. All right, and I go back, and so what number goes here when I take away from 64? I get 30, and that's 94. And finally, what number goes here when you take it away from 142? You get 94. All right. Well, if you notice, there's a pattern here, right? This plus that is 30. This plus that is 94. So this plus 142. So 142 plus 94 should give me the number that when you subtract 142 from it, you get 94. So 236. And this is neither. It's neither arithmetic or geometric. All right, let's look at part B now. So in part B, I have this sequence 28, 32, 128, and 512. So am I adding? Let's see. So 2 plus 6 is 8, plus 6 is 32. No. How about multiplying? Well, 2 times 4 is 8, times 4 is 32, times 4, let's see, 32 times 4 is 128, and if I multiply by 4 again, I bet I get to 512. So the next term, I multiply by 4 again, and I get 2,048. So the answer for this one, the next term, is 2,048 from my inductive reasoning skills. And this is, I'm multiplying by 4, right? So I'm multiplying by 4. So this is an example of a geometric sequence. Okay. And then finally, this is probably an arithmetic sequence, but let's test it. If I add 5, I get to 8. If I add 5, I get to 13. If I add 5, 18. Add 5, 23. And if I add 5 more, I get to 28. So I'm adding 5 each time. And so this is an arithmetic sequence. All right, let's go back to the review. All right, so now we talked about arithmetic versus geometric, this method of successive differences. Let's move on to 5.2. So on 5.2, we talked about problem solving. We talked about a particular type of problem. We talked about these optimization problems. And the idea behind an optimization problem is you're trying to find the optimal value to answer the question. So typically, in our case, it's either the maximum or the minimum. And the way we do this is we do PEST. Picture, equation, solve, and test. And we really don't ever use test because we're kind of using it in the solving part. And so let's take a look at an example from the review here. And let's go to the next page. And so flip it over. And look at number 5. Okay, so on number 5, what we have, it says you would like, let's see if we can't make this a little bit bigger. Well, that's not bigger. Okay. It's a little bit bigger. Oh, that's not what I want either. Alright, about to give up here. Now, here's zoom. Let's go to 150. Alright, let's just keep it here. Okay. So it says, number 5, you would like to enclose a 480 square foot rectangular region for your dog in the backyard. You would like to fence 3 sides with materials costing $15 per foot and 1 side costing $10 per foot. Find the minimal cost. All right, so how do we do this? All right, so let's draw a picture. All right, we know we need a rectangular area. So here's my rectangle. This will be X. This will be Y. This will be X. This will be Y. It has 480 square feet. Since it says square feet, I know that's area. So this is 480 feet squared. Fence 3 sides with materials costing $15 per foot. So let's change the color up here since I have other colors I can use. So let's do these 3 sides. 1, 2, 3. And this is $15 per foot. And then the other side, let's do it in green. All right, this is going to be $10 per foot. All right, so you have $15 per foot in blue and $10 per foot in green. And then I want to find, it says, the min cost. So find min cost. All right, so now I'm going to look for my equation. So for my equation, I need to find a cost equation because that's what I'm trying to minimize. And the idea is if this was just 1 foot, I know it'd be $15. 2 feet, 15 times 2. 3 feet, 15 times 3. X, 15 times X for that one side. And of course, the vertical side would be 15Y, and the other horizontal side is the same as this side, so 15X. Then plus this side, which isn't 15Y, but 10Y, because it's $10 per foot, so 10Y. And you add these together, and you get 30X plus 25Y for your cost. All right, so now what I would like to do, I'd like to graph this, graph the left, graph the right, not graph the left, graph the right, just graph the cost function and find the minimum or maximum. So it should go down and go up. But the problem is I have not one letter, but 2. So I have to get rid of 1, and that's where this number, 480, will come into play. So 480 is equal to, that's area, so it's X times Y, and I can solve this for Y. Right? Y is equal to 480 divided by X. And so I can plug in here for Y, so C is equal to 30X plus 25 times 480 divided by X. So I just replace Y with what it's equal to. And I can simplify this a little bit. Right, 35 times 480, 35 times 480 is equal to 16,000. Not 35, sorry. I meant 25. Is equal to 12,000. So I have 12,000 divided by X. And now I'm going to solve. Right, so to solve this, I'm going to graph it. Right, so I'm going to graph this thing. So I hit Y equals, and I plug in 30X plus 12,000 divided by X. And I'm going to make my window, and I'm going to go from 0, and it's 480 feet squared, so I'm going to go to 0, and let's go to 100 feet first. Let's see if that's enough. So I'll go from 0 to 100, and I'll zoom fit it, and it goes down, and it comes up. Good enough. It goes down, and it comes up. And I'm looking for this minimum, right? So I'm going to hit the minimum button. So I hit second trace to pull up the calculate menu. I go down to, oops, wrong one, second trace, and I go down to minimum, which is number 3. Right, so I hit enter on number 3, and it says left bound. Well, 0 is definitely to the left of the minimum, so I'm going to hit 0, enter. And then 100 is definitely to the right, so I'll just hit 100 and enter. That way I don't have to deal with the arrow buttons. And hit enter for a guess, and I'll spit out my answer. So X is 20 feet, while the minimum cost, right, this output is C. The minimum cost is $1,200. So C, the minimal cost here, is $1,200. All right, so that's a nice example of how to solve an optimization problem. Okay, on 5.3, we talk about basically the foundations of mathematics, which uses sets, and then we use Venn diagrams to answer questions about sets. So remember a couple things, okay? So this notation, this means a set of things. So as an example, I could take the set 1, 2, 3. Right, so it's just 1, 2, and 3. We can talk about elements of, like 1 is an element of the set, so that's what this symbol means. Subset, like the set 1, 2 is a subset of the set 1, 2, 3. Union, you can combine sets. Intersection, you can intersect them. And then these absolute value symbols, they mean the cardinality, which is simply the number of things in a set. So let's take a look at the review, because there's a couple problems on the review. in which we work with these symbols. So let's look at number 3. All right, so on number 3, what is it saying? So we want to basically, I'll blow this up. That's better. Okay, so on number 3, what it's saying is true or false, and if it is false, then correct the statement so it's true. So is 3 an element of A? Yeah, 3 is an element of A, so this is a true statement. Is 9 an element of B? That's a false statement. There is no 9 in the set here, 2, 3, 5, 11, 17. To make it true, you just put a slash through it. A is a subset of B. Okay, well, 3's in B, 7's in B, 11's in B, but how about 13? No. So this is actually false because 13's not in B, so it's not a subset. Put a slash through it. 2, 3, 5 is a subset of A. That's obviously false. All right, so that's a false statement. Again, you can make it true by saying not a subset of A. A union B is 3, 7, 11, 13. Well, union, you have the 3, you have the 7, you have the 11, you have the 13, but you come over here and you don't have the 2. All right, so this is also false, and you can put a line through it, because if it was true, then it would contain all the elements in B also, so but it doesn't contain 2. A intersect B, this is what they have in common, so they have a 3 in common, yes. They have a 7 in common, no. They have 11 in common, yes. They have a 13 in common, no. So yes, this is a true statement. They have 3 and 11 in common, and that's it. Nothing else. The number of things in 6, the cardinality of the cardinality of A is 6, which means the number of things in A is 6. That's false. There are 1, 2, 3, 4 things in there, so this is false. You can make it true by just putting a slash through it, or you can even make it true by saying the cardinality of A is equal to 4. The cardinality of A union B is 7. Well, let's first find out what A union B is. So I can look up here, A union B. Let's start with the smallest element, which is 2, because you just combine them. So you have 2, 3, go in order, 5, there's no 6, 7, all the way up. The next one is 11, and then 13, and then 17, in parenthesis, in bracket, right, curly bracket. So 1, 2, 3, 4, 5, 6, 7. That's true. All right, so A union B does have 7 things in it. Okay, and so let's do an example with Venn diagrams and counting. So if you go to, and let's do a couple examples. Let's do this example, right, which is the one we did in class, which students often miss when I put it on the exam. Not saying I'm going to put it on the exam, but when I do, they often miss it. And the idea is real simple. You just want to put the right numbers in the right spot. So there's 3 sets, A, B, C. There's 3 circles, so let's call this the A circle. Let's call this the B circle and the C circle. And you just go through these, right? 3's in A, 3's in B, 3's in C. So where do you put it on all 3? Right in the middle. 5's in A, 5's in B, 5 is not in C, so it's just in A and B, so it goes right there. 7's in A, 7's in C, so 7 is in A and C, but not B. 9 is in A, and then nothing else, so 9 just in A. And 10 is in A, and nothing else, so it's just in A. 1 is in A, C is in A. 1 is in B, C is in B, so that goes here. 2's in B, 2's not in C, so 2's just in B. And 4's in B and 4's in C, so it goes right here, B and C. And finally, 6 is in C and 8 is in C only. And then you can answer all of these questions. Let's just do one of them. Let's do 2 of them. Let's do the first one, right? A union B. So what is it? Right? What is this set? So I use curly brackets for a set, and I take everything in A and everything in B. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. But not 6, because 6 is just C. But yes, 7. There's 7. And then not 8, because 8 is just in C. I just want the things in A and B. And then I take which one? So not 8, but 9. And then finally 10. And that's it. So there are 1, 2, 3, 4, 5, 6, 7, 8 things in there. let's do the hard one. The hard one's down here at E, and let's change up our color. So why don't I use, let's use green. Okay, so first I'd look for, let's do part E, A intersect B. So A intersect B is right here. And then I union it with C, so I combine it with C. So that's all this stuff in C. And so my answer for this one, is the set of, what? 1, but not 2. There's 3. There's 4. There's 5. There's 6. There's 7. There's 8 in green, but 9 and 10 are in red, so they're not in the green, so they're not in there. So just 1, 3, 4, 5, 6, 7, 8. And then how many things are in there? 1, 2, 3, 4, 5, 6, 7. So the cardinality, right? Remember, these mean the number of things in that set is equal to 7. Let's also turn our attention to the review, because on the review, do we have one? Oh, I guess not. I didn't put one of these on the review because we did it for the question of the day. And those of you that did Monday, Wednesday, Friday, you might want to look back at that one. We did that last time in class, but it won't hurt to look back at the question of the day. All right, so let's go back to the review on the PowerPoint. And so we did Venn diagrams. We did a counting exercise for today's question. And so now let's look at the logic puzzle. So in the logic puzzles, we did 2 types. We did one with the Venn diagrams, and then we did those logic tables. Remember, for the logic tables, you'll be given a problem just like the one in the homework and on the group work. And you don't have to do it during the exam, although it's a bonus if you finish it during the exam. But you do have the option of taking it home and doing it and then returning it the next class period. But let's look at the one that uses Venn diagrams on the review, so we can kind of look at that. And so this is number 4. And it says, some doodads are mullets, and all mullets are tails, and all hops are mullets. Which of the following conclusions are valid by the following premises? Or premises. Okay, so what do we do? All right, you have to draw a picture, right? So you want to figure out, are all hops tails? Some hops are doodads, some mullets are hops, some tails are doodads, and so on. So draw some pictures. So some doodads are mullets. So what you can do is you can draw a doodad circle. So this is my doodads. And now some just tells me it overlaps a little bit. So this is my mullet circle. So that's mullets. And then I get to the next one. It says all mullets are tails. And so I'm going to draw a tails circle. So I'm going to make it all. But I'm going to be careful how I draw this. Right? It doesn't say that I go past the mullets. So this is my tails circle. And then over here I have all hops are mullets. So inside here I have a hop circle because all hops are mullets. So I'll have to draw an arrow. Right? This is my hop circle. Okay, so from this picture, hopefully I can answer these questions. So all hops are tails. All right, well, here's the hops, and certainly they're all inside the tail, so I think this is valid. All right, and then the next one says some hops are doodads. Well, here's the hops, but it doesn't look like they necessarily overlap the doodad, so this is an invalid conclusion from my assumptions. All right, invalid. And then some mullets are hops. Well, here's some mullets. And here's hops. Yeah, certainly, right? Hops is contained in the mullet circle. So some mullets are hops. So that's a valid conclusion. And then some tails are doodads. Okay, some tails are doodads. And this is valid also because all the tails include all the mullets are included in the tails, and some of the mullets are doodads, so some of the tails are also doodads. So this is valid. And you can see this from the picture. Right, the tails include this piece here, which are doodads. And that's it. Right, so that completes the review for exam 5.